Hello everyone. In this next part of this simulator video, we are going to look at some relationships between different variables. So in this first one, we're going to look at temperature and density. So what I'm going to do first is I'm going to heat this up and I'm going to take note of what I see happening. So as I heat it up, my particles are moving further apart from each other. And as they cool down, they are getting closer together. So I'll hold it on cold for a minute so we can see them getting closer together. So I'm going to record that here in my packet. So as the temperature goes up, the particles spread out. And as the temperature goes down, the particles get closer. So let's think about this in terms of density. So if my temperature is increasing, the particles are getting further apart. So that means my density is going down, because remember, density is how compact our material is. So if I increase the temperature, they spread out. So my density is decreasing. And if my temperature was going down, if I was making it colder, the particles are getting closer together. So it's becoming more dense. My density is going up. So I'm going to write that down in full sentences at the bottom here. As temperature increases, density decreases. And as temperature decreases, density increases. And this is because as we are giving it more temperature, they are able to spread out more, so it's less dense. As we remove temperature, we bring the temperature down, they get closer together, so it's more dense. Okay, I'm going to flip to page 13. So now we're going to look at something else. So this time I'm going to make sure I'm in a gas, and this time we're going to look at pressure and density. So I have my gas flying around, and I'm going to increase my pressure by pushing down on the lid. So as I increase my pressure, we can see our gas molecules getting closer and closer together. As I decrease my pressure, as I pull up on the lid, they're spreading out. So when I push down on the lid, they get closer. When I pull up on the lid, they get further. So if we think about this in our terms, as pressure increases, the particles are getting closer together, so it's more dense. Density increases. As pressure decreases, density decreases. They get further apart. Oop, wrong way. Boop, boop, boop. Now, the last thing I want us to look at is what happens to temperature when I change the pressure. So we need to look closely at the temperature here. So right now it's 132 Kelvin. And I'm going to push down, and what I start to see is that it's going up. Now it's 230, 240, 260, 280 Kelvin. Oop, I made the lid fly off. So as I push down, as pressure increases, the particles move faster. They are bouncing off of each other so much. Let me show you again. So I push down, they start to bounce around and bounce around and bounce around, and they're bumping off of each other, and they move faster. Now when I, if I I decrease my pressure, we can see that there's more space, so the particles move slower. Now, here's what we need to talk about. Our speed of our particles is what we use to measure temperature. So really what we're saying here is that as pressure increases, they're moving faster, which means temperature is increasing, which we can see in our numbers. As I push down, the temperature goes up because they're bouncing around so much faster. When I lift the lid up, when I remove pressure, the temperature goes down because those molecules, those particles are moving slower. They have more space to move, so they slow down. So as pressure increases, temperature increases because as we're pushing down, they're bouncing around and they're moving so much faster. So the temperature goes up. As pressure decreases, temperature decreases. They have more space to move, so they move slower, and so our temperature is lower. Now, the last part of this activity is extra credit. So I'm not going to do it here for you, but on 13, and then if you flip your page to page 14 as well, at the top of page 14 right here, what I want you to do is see if you want to earn a little extra credit, see if you can get the lid to pop off of the simulator. And then explain how did you make the lid pop off. So you can tell me one way you made the lid pop off, and then on the back on page 14, you can make another example of how you made the lid pop off. Okay, so make sure you have this down in your packet, and make sure if you want to earn a little extra credit, you mess around with that simulator and try to get the lid to explode off the top of the container. I hope this helped, and have a wonderful day.